So this is a very good place to start dynamic programming. This question number 123 of Leetcode. So it says that what is the best time to buy and sell stocks, where you can have a maximum, where you want the maximum profit that you can achieve out of like selling and buying these stocks, and you can have at most two transactions. So let us just dive into example. We do not want to read any of these text apart from this thing, right? So the here we have the prices array, and where prices I is the price of a given stock on the ith day. Now this means that we can like buy stock on the first day and then sell it say on the third day, and that would give us a profit of two, right? So something like that. So now obviously we need to make only two transactions, and that means that we have to take the best two transactions that are possible, and we should be able to generate the maximum profit from this. So let us just think about what the approach should be. So first off, like if the number of transactions were infinite, which will be the content of the best time to buy and sell stock 2, then you will obviously be using a greedy approach, right? Because you will be buying and then selling whenever you are getting whenever you are getting the next day price to be greater. So like you buy and then you sell for an immediate profit, and then you buy again and keep doing so. So that would be the approach when the number of transactions are infinite. But of course we cannot do this if there are like two transactions or a cap, right? So what we are going to do in this situation is like we are going to call a recursive function that checks out all of the different possibilities and the different combinations that we can take on. Now, why dynamic programming is like very useful in this situation is because we expect some of the situations that we need when we are like generating the recursive base cases to be like repeated a lot of times. So that would be the reason why we are going to use DP, and why it would be a very reasonable thing to apply here. And also like you will be able to understand, right? So like this like there are like infinite number of, like there are a lot of combinations that you can obviously not like pass through and like have a optimal solution just by a glance. So like you are going to be you need to like uh, check out all the strategies and select the optimal one only after you have already checked out most of these strategies, except for like a few trivial ones which will like reject immediately. So let's just dive into the solution that I have written. This is like very easy to understand. So first off, whenever you are writing a DP solution, like think of what you want to achieve, right? And these are like some of the basic rules, like think of what you want to achieve, think of what you already know, and try to express everything in terms of an array where each of the indexes represents some kind of state, right? Now if this is a 3D array, then this means that you can like here it is a 3D array, right? So like you have to see like the number of independent variables that you have to account for in order to check out all of the possible states that can occur while you are like building the recursive solution, right? So here basically what are the three variables, right? Like this is one, like the indexes of the prices, like the time variable, right? The number, the nth day, the ith day, the number of the day is one of the variable here. Now you will also be like noting down how many transactions you have already done. So that should be another variable, right? So let's just like use here a cap variable, right? So like you know that how many transactions you can do next. So this is what cap represents here. And then you also need to like certain that whether you can buy in the first place in the either day, right? So if you have like because this is a very important restriction here, you may not engage in multiple transactions simultaneously. So like you have to maintain some kind of mechanism where you can like check out that if you can buy in the first place. If you have already a stock in your stockpile, then you will not be able to buy. So this should be another variable. So now this means that we are just going to have an index size into two like into three, right? Because cap can like vary between 2, 1 and 0, which means that the number of transactions that you have remaining is 2, 1 or 0. Okay. So what I said earlier, like what is the objective of the problem? So we have to check out what is the maximum profit we can achieve after all of these days, and provided that we make a maximum of 2 transactions. Okay, so to put that in like DP terms, we are going to we are going to check out all of the transactions we can do after the 0th index, like the 0th day, which basically means like the entire time frame, and we can buy at the starting of the time frame, and we are allowed to do a maximum of 2 transactions, right? So this is our objective. So like you have to like have a clear idea of the objective that you are trying to pursue. Okay, so now let us just think of the recursive cases, which are like pretty easy. So like there are like let's say like there are 4 cases. Okay, so like so first off, let's just write the base cases. So there are like you will be able to propagate, right? So okay, let's just do the base cases later. Let's just think about what we should do before the base cases, right? So basically, first off, the simple rule of DP that whenever you already have a value available, then you use that value, right? So this part is clear. This part is clear. Okay. Now the other part. So basically, if you can buy, right? If you do not have any stocks with you, then what is the maximum profit that you can make from that day, given that you can buy, and you have and we will maintain this cap. Okay, we will maintain this cap, and given that you have cap number of transactions remaining is the maximum of this amount. Let's just break this down. So this amount, this means that you have bought the stock that is present in the ith day. So this gets reduced. Okay, like this is like you do not have this money, right? You just paid it to somebody, and then you you can like from that day, if you cannot buy, then what is the number of what is the maximum profit you can gain from that day if you cannot buy. Okay, so basically this is what it boils down to. Now let's just see this one. Is this and the second case basically is that you do not buy the stock that is present in the ith day, right? So like you just move on to the next day, and you keep the power to buy a stock, and you have a cap number of transactions remaining. We'll not change cap here, because we like transaction is of like has 2 distinct parts, right? Buying and selling. Now we are using selling to mark our transactions because it's like the second part of the transaction. Otherwise, you can probably use buying as a marker as well, and you can probably make it work. But let's just use selling for simplicity. So you are basically going to like oversee the number of transactions you are making whenever you are selling something. then you just like reduce the number of transactions that are available to you by one. And this is exactly what has been done. So like if you do not have the capability to buy something, this means that you have a stock available with you. You have a stock available with you, which means that you can sell the stock at this price, at the ith price. Okay, so this means that this quantity, we can obviously understand this very clearly by now, is that the this is like the f index 0 cap, right? So the maximum profit that you can generate from the index day onwards, provided that you do not have a buying capability, and given that you have cap number of transactions remaining, is the maximum of these two values. Let's just again break this down. So this is the case where we sell the stock that we have with us. We sell the stock. So what does this do? This does uh, this increases the price index amount to our budget, right? To our like total money. So this means that the prices index amount, we just sold our current stock for this amount, and then we like we take back our capability to buy the stock again, right? But the number of transactions has reduced. Okay, so this is just that. And then for the second part is the part where we do not sell the thing. So this means that we just increase the number of days, like the index of the days, which means that we are skipping the day for that day, and we are preserving our capability to actually sell, which is indicated by the zero here. And we have cap number of transactions remaining because we are not selling anything in this either day, right? So, and we return this dp. Notice the style of writing here. Like whenever you have the solution for a particular day and particular state, then you store it in a dp, right? So you store it in the dp array, and then you return the dp element, right? So that's how you like memorize. Okay, so, and notice this is a very interesting thing that I have noticed that students often miss out, is that like you do not need to pass the prices variable, the base variable again and again into your recursive dp function. Okay, because that would be very cumbersome, and it will obviously not change 1,000 times, right? Like you do not want to write this down inside f. Okay, and you do, because this would mean that your solution is becoming cumbersome, and cumbersome you have to write this again and again, even though this is not changing, right? You are not modifying prices. So what we do here is like we introduce it as a class variable. It's very simple. We introduce it as a class variable, and then we don't forget to do this. Okay, this price is equal to prices. This will like convert the class variable into this specific prices variable that you are getting from the like Leetcode console or whatever. So that is the idea of this. Now if like there are like more than two suppose like at most like 10 transactions, then you will just modify cap here. Okay, it's very simple. Also, yeah, the like do not fumble about this line. Okay, like learn up how to write this, like vector 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 int. Okay, so like you first write down what you are making the vector out of, and then you give in the default values. In this case, I have mentioned the default value as -1, which is how I check if the dp value has been entered into the in process or not. Okay, so yeah, that's it. That's all for this problem. This is a very like beginner level problem, but it's a very useful place to start. It's a very useful place to start. And do not consider about this hard problem. This is like pretty easy. It's not difficult at all.